This is SpaceTime, Series 23, Episode 135. Coming up on SpaceTime, new evidence of how dark matter behaves, new discoveries about how planetary nebulae are created, and Cape Canaveral renamed. All that and more coming up on SpaceTime.
Welcome to SpaceTime with Stuart Gary.
Astronomers have discovered new characteristics about mysterious dark matter after watching one galaxy being eaten by another bigger galaxy. Previous observations had already suggested that this galaxy, catalogued as NGC 1052DF4 and located some 45 million light-years away, was missing most of its dark matter. Scientists don't know what dark matter is, but they can see its gravitational influence on galaxies, stopping them from spinning apart as they rotate. Dark matter seems to interact with normal matter only gravitationally. And dark matter's interaction with normal matter suggests that it makes up at least 3/4 of all the matter in the universe, far more than all the stars, planets and galaxies which are composed of normal matter. Astronomers studying the light and globular cluster distribution in NGC 1052DF4 detected gravitational tidal disruptions being caused by a larger neighbouring galaxy, NGC 1035. A report in the Astrophysical Journal concludes that NGC 1035's gravity has stripped the dark matter from NGC 1052DF4, and the galaxy is now being torn apart. The new observations follow the 2018 discovery of another galaxy, NGC 1052DF2, which is also missing most of its dark matter. That was the first time this has been observed in our cosmic neighbourhood. The discovery was a surprise for astronomers, as it was understood that dark matter is a key constituent in current models of galaxy formation and evolution. In fact, without dark matter, the primordial gas would lack enough gravity to start collapsing to form new galaxies. Now, the discovery of a second galaxy, NGC 1052DF4, also lacking dark matter, has triggered intense debate about the nature of these objects. The study's lead author, Maria Montez from the University of New South Wales, says the missing dark matter can be explained by tidal disruption. As NGC 1035 tears NGC 1052DF4 apart, the dark matter is being removed first, leaving the stars and other normal material to be removed later. And that's telling astronomers something very specific about the nature of dark matter. Until now, the removal of dark matter in this way has always been hidden from astronomers. But thanks to Hubble's high resolution, astronomers could identify this galaxy's globular clusters. Globular clusters are thought to form in episodes of intense star formation that shaped galaxies. These tight balls contain thousands to millions of stars, all originally born at the same time out of the collapse of the same molecular gas and dust cloud. They're both compact and highly luminous, making them easily observable. And they're therefore good traces of the properties of their host galaxies. Studying and characterizing the spatial distribution of these clusters in NGC 1052DF4 allowed the authors to develop new insights into the galaxy itself. They found the alignment of the galaxy's globular clusters suggests they're being stripped from the galaxy by its larger neighbour, supporting the idea that tidal disruption is occurring. The authors also used the giant 10.4-metre Gran Telescopio Canaris telescope and the IAC-80 telescope, both on La Palma in the Canary Islands, to provide additional data on the galaxy and its light. They found evidence of gravitational tidal tails formed by stars, gas and dust being dragged away from NGC 1052DF4 by NGC 1035, further evidence of tidal disruption events. Additional analysis concluded that the central parts of the galaxy remain untouched, and only about 7% of its stellar mass is in these tidal tails. The findings mean dark matter, which is less concentrated than stars, was previously and preferentially stripped from the galaxy, and now the outer stellar components are starting to be stripped as well. This is SpaceTime. Still to come, new discoveries about how planetary nebulae are made, and Cape Canaveral gets a new name. All that and more still to come on SpaceTime. Astronomers have discovered that those mesmerising spiral structures seen in planetary nebulae are generated by companion stars or planets orbiting around the dying star. The findings, reported in the journal Science, are based on an extraordinary set of observations of stellar winds around aging stars. When stars like our Sun run out of core hydrogen for fusion into helium, they begin to contract under their own enormous gravity. Now, as they contract, regions around the stellar core which still contain hydrogen move closer to the core and the region where pressures and temperatures allow hydrogen fusion to take place. This triggers hydrogen burning in a shell around the core, which causes the star's outer layers to dramatically expand. And being further away from the core, the star's photosphere or visible surface is noticeably cooler and consequently looks redder. The star, now called a red giant, experiences a massive increase in its stellar wind production as more and more materials flow out from its gaseous envelope. Meanwhile, the increase in pressure and temperature in the core eventually triggers what's called a helium flash, fusing the core helium into carbon and oxygen. Stars like the Sun don't contain enough mass to fuse carbon and oxygen into heavier elements, and so their stellar evolution ends. The core, now detached from its outer gaseous envelope, is exposed as a white dwarf, slowly cooling over the eons of time. And the detached gaseous envelope is referred to as a planetary nebula. But how do these planetary nebulae get their stunning shapes? Well, the study's authors found that, contrary to common consensus, the stellar winds generated by stars, including the Sun, are not spherical, but have a shape similar to that of planetary nebulae. That's because of their interaction with accompanying stars or planets. Stellar winds, including the solar wind coming from the Sun, are streams of particles expelled by stars, which causes them to lose mass. Now, because detailed observations were lacking, astronomers have always assumed that these winds were spherical, like the stars they surround. For centuries, astronomers were in the dark about the cause of the extraordinary variety of colourful shapes of planetary nebulae that had been observed. All planetary nebulae seem to have a certain symmetry, but they're almost never round. One of the study's authors, Professor Leen Deason from the Catholic University in Leuven, Belgium, wanted to know how round stars could produce the spectacular shapes seen in planetary nebulae. Her team observed stellar winds around cool red giant stars using ALMA, the Atacama Large Millimetre Submillimetre Array Radio Telescope in Chile. They gathered a large, detailed collection of observations, each made using the exact same method, thereby allowing them to directly compare data and exclude biases. Deason and colleagues found that stellar winds aren't symmetrical or round. They can be disc-shaped, others can be spirals, and yet others are shaped more like cones, shapes all very similar to those seen in planetary nebulae. Now, this is a clear indication that the shapes weren't created randomly, suggesting that other low-mass stars or planets, too small and dim to be detected directly, are orbiting in the vicinity of the dying star, causing the different patterns to form. Deason says these companions are a bit like a spoon stirring cream into a cup of coffee and creating a spiral pattern. The companion sucks material towards it as it revolves around the star and shapes the stellar wind. And computer models based on their hypothesis has confirmed that the stellar winds were being shaped by companions around the primary star. And the rate at which the star is losing mass due to the stellar wind is an important parameter. Deason says the new findings mean previous mass loss estimates of old stars could be wrong by a factor of up to 10, and that would affect calculations of other crucial characteristics of both stellar and galactic evolution. The study also helps to envision what the Sun might look like when it dies in 7 billion years' time. Deason says the large mass of Jupiter or even Saturn will influence the Sun's eventual planetary nebula, with initial calculations suggesting it'll end its days as a white dwarf surrounded by a weak spiral structure.
Together with a team of international astronomers, including quite a lot of my PhD students and postdocs from the KU Leuven, we have made a breakthrough discovering stellar evolution. So what's it all about? You potentially know that our Sun is a very little yellow star. And in roughly 5,000 million years from now, the Sun will become a red giant star. Its size will increase by a factor of 200, its luminosity by a factor of thousands, and it will become cooler. And as such, it will change from color from yellow to red. And during that phase, we know that stars lose a lot of mass by a stellar wind. Now, actually, after that red giant phase, Our Sun will become a planetary nebulae and it will die as a very little white dwarf. Now, planetary nebulae, you potentially have seen already very nice pictures on these. These planetary nebulae have been imaged by, for instance, the Hubble Space Telescope, and you can see a lot of very complex morphologies. You have disks, you have bipolar outflows, you have even planetary nebulae that look like a butterfly. But already for more than a century, astronomers were wondering, how can a star as our Sun, which is more perfectly round than a billiard ball, how can it get these complex phases? We have used the ALMA telescope in Chile, the largest radio telescope in the world, to look at the stellar winds of red giant stars. We have seen that each of these winds, of which we thought in the past that they were spherically symmetric, we have seen that each of these winds harbors a lot of complexities, and that the morphologies in these stellar winds resemble the morphologies that we see in the planetary nebulae. And this led to the first conclusion, that it should be the same physics that shapes both the stellar winds and this planetary nebulae, and as such that we have caught the mechanism in action. But moreover, we could use all of this data to make categories in the stellar wind morphologies. And that led to the second and even most important conclusion, that we finally could diagnose the cause of these morphologies. We think that each of these stars do not live their life alone, but has a companion. And then you can compare it with a cup of coffee and some milk, and when you stir in it with your little spoon, you can create a spiral structure in your coffee. Well, actually, the companion is doing the same. It goes around the red giant star and it creates a spiral structure, a very complex spiral in the stellar wind. It can also create a disk, for instance. So what does it imply for our own Sun? Well, actually, our simulations show that, unluckily, our own Earth will be engulfed by our Sun when the Sun is a red giant star. Planets as Jupiter can survive, and Jupiter, for instance, will create a very weak spiral structure in the stellar wind of the Sun once it is a red giant star. So this research is a breakthrough discovery, since it changes our view on how stars evolve at the end of their lifetime.
That's Professor Leen Deason from the Catholic University in Leuven, Belgium. And this is SpaceTime. Still to come, Cape Canaveral renamed, and later in the science report, warnings that climate change could lead to irreversible sea level rise as temperatures increase. All that and more still to come on SpaceTime. One of the most famous places on Earth, the Cape Canaveral Air Force Station in Florida, has been officially renamed the Cape Canaveral Space Force Station. The move by the US Air Force, which we first foreshadowed a year ago here on SpaceTime, is designed to better reflect the primary operations of this vast facility, spread out along the central Florida Atlantic coast. The Air Force has also changed the name of the nearby Patrick Air Force Base to the Patrick Space Force Base. Both bases, which are heavily involved in Space Force operations, will still be overseen by the Department of the Air Force, which also oversees the Space Force, in the same way as the US Department of Navy oversees the US Marine Corps. The renaming ceremony, which was witnessed by Vice President Michael Pence, also marks a year since President Donald Trump officially signed the documents bringing the United States Space Force into existence. This is SpaceTime. And time now to take another brief look at some of the other stories making news in science this week with the Science Report. A new study warns that the worsening problem of climate change could lead to irreversible sea level rise as temperatures continue to increase and the Greenland ice sheet continues to decline. The findings, reported in the journal Cryosphere, show that this massive ice sheet is now facing a point of no return, beyond which it will simply no longer be able to recover. permanently changing sea levels around the world. The Greenland ice sheet has 7 times the area of the United Kingdom, and it stores a large amount of the Earth's frozen water. At current rates of melting, it's contributing almost a millimetre of sea level rise every year, and overall it accounts for a quarter of all sea level rise. Under scenarios in which global warming increases beyond 2 degrees Celsius, scientists expect significant ice loss and several metres of global sea level rise to persist for tens of thousands of years. And even if temperatures do later return to current levels, scientists have shown that the Greenland ice sheet will never fully recover once it melts beyond a critical point. After that point, sea levels would permanently remain 2 metres higher than now, regardless of other factors contributing to sea level rise. That's because this ice sheet is so huge it has a substantial impact on its local climate. And as it declines, Greenland will experience warmer temperatures and less snowfall. And once the ice sheet's retreated from the northern part of the island, the area would remain ice-free. A new study warns there are now fewer than 300 swift parrots left in the wild. The findings by the Australian National University suggest this highly endangered bird is now facing extinction because of major threats such as deforestation. The swift parrot leads a nomadic lifestyle, flying around Tasmania looking for the best breeding habitats and travelling to mainland Australia each year looking for food. You can read the study and its findings in full in the journal Animal Conservation. Scientists have sequenced the genome of Solanium pimpinellifolium, the wild progenitor to the modern-day cultivated tomato. Tomatoes are the world's leading vegetable crop, with total production of 182 million tonnes worth over $60 billion annually. Solanium pimpinellifolium carries small red round fruits. They were first domesticated in South America, gradually evolved to become the big fruited tomatoes we see today. A report in the journal Nature Communications compared Solanium pimpinellifolium with the modern cultivated tomato called Heinz 1706, finding more than 92,000 genetic variants. Interestingly, scientists found that modern cultivated tomatoes had some genetic deletions which reduced their level of lipocene, a red pigment with nutritional value, and an insertion that reduces their sucrose content. No wonder they're said to have less taste than their ancient wild varieties. The only dinosaur bones ever found in Ireland have been formally confirmed for the first time. A report in the journal The Proceedings of the Geologists Association have verified that the 200-million-year-old Jurassic Age fossils found on the east coast of County Antrim came from 2 different dinosaurs. One of the fossils is part of a femur, very dense and robust, typically from an armoured 4-legged platypus called Scelidosaurus. The other fossil, part of a tibia, was slender, with thin bone walls and characteristics only found in fast-moving 2-legged predatory theropod dinosaurs similar to Sacrosaurus. Robot vacuum cleaners that spy on private conversations and faulty display modules affecting the touch response on some iPhone 11s are among the latest developments in the world of technology, with Alex Zaharov-Reutt from ITY.com.
We had the story of Google with its Nest thermostat device that got an upgrade, and suddenly you could use it as a Google Home speaker, a Google Assistant speaker. And people thought, well, hang on, you're telling me that there was a microphone? You never advertised that. You know, there's lots of devices, TVs and other things. There's a reason why a lot of the TVs don't have built-in cameras on them anymore, because a lot of the TVs have been hacked and people were being spied upon in their own homes.
TVs had cameras in them?
Yeah. Back about 10 or 15 years ago, the first smart TVs had cameras in them because they had built-in Skype, and people were using them, long before COVID and the Zoom revolution we have now. They were using them as giant Skype devices, but they got rid of those. I mean, the camera manufacturers no longer make them, mainly because these TVs are hackable. And there was even a story where former Prime Minister Tony Abbott was in China and they suspected something was wrong, so they turned the TV off, and then housekeeping came and turned the TV back on. So when the guy left, they took the TV and put it outside because they were worried that the TV, which had microphones and cameras, or at least microphones, was being used to spy on whatever private conversations were happening in that hotel room. And that's the story I read. I don't know if it's true, but
yeah, that actually happened. But do TVs still have microphones in them these days?
Yeah, absolutely. Yeah, there's a brand new Hisense TV that I'm not sure whether it's in the remote control or the TV itself, but you can talk to the TV. It's got built-in Alexa and Google Assistant, and you can ask the TV to turn on certain channels or turn the volume up or down, or if it's got a built-in personal video recorder to record things. So absolutely, a lot of televisions do indeed have microphones if they're brand new smart TVs.
I know the IQ4 has a microphone in it. Because
that's right, yeah. And that took, several months to be switched on, but now they're advertising it on TV.
Robot vacuum cleaners spy.
Well, computer scientists at the National University of Singapore have demonstrated that it is possible to spy on private conversations using a common robot vacuum cleaner and its built-in light detection and ranging sensor, which is known as LiDAR. They're repurposing the LiDAR sensor that the robot vacuum cleaner normally uses to navigate around your home into a laser-based microphone, which can be used to eavesdrop on private conversations. Now, the robot vacuum cleaner doesn't have a microphone built in, but the LiDAR sensor, which fires out an invisible scanning laser, which normally is used to create a map of the home, the surroundings, where the legs and the chairs and the tables are and all that sort of thing. Yep. So they reflect the lasers of common objects like the dustbin or whatever it might be, and the attacker could obtain information about the original sound that made the object surfaces vibrate. And using applied signal processing and deep learning algorithms, so that speech can be recovered from the audio data and sensitive information can potentially be obtained.
Yeah, spies do that now with the Windows, don't they?
Well, apparently they do. The team says that it collected more than 19 hours of recorded audio files, passed them through deep learning algorithms that were trained to either match human voices or identify musical sequences, and the system was able to detect digits being spoken aloud, which could constitute credit card or bank account numbers.
So does this mean that I really should keep my cell phone in the microwave oven when I'm not using it and I'm having a confidential conversation with somebody?
Well, that's what Edwin Snowden did, apparently, when he had people come to visit him before he was spirited off to Russia. He asked journalists or whoever it was to put their phones in the fridge because it was a Faraday cage that would basically stop any signals going in or out. But it's just incredible that a lot of the things predicted in 1984 or in previous sci-fi movies, as the amount of artificial intelligence and machine learning increases, these things become possible.
There have been issues with the iPhone 11. Tell me about them.
Yes. Well, Apple has determined that a small percentage of the iPhone 11, and that's the iPhone 11 only, not the iPhone 11 Pro, that their displays may stop responding to touch. And that's due to an issue with the display module. Now, these devices were manufactured between November 2019 and May 2020. So it's not all iPhone 11s. It's just a select number of them. And Apple says that if your iPhone 11 has been exhibiting this issue, if you just type in iPhone 11 display program, you'll find a link somewhere on Google that will take you straight to Apple's support page. And then you can type in your iPhone 11 serial number to see if affected. They will replace the screen free of charge, and they'll do that for 2 years pretty much from now.
That's Alex Zaharov-Reutt from ITWire.com. And that's the show for now. SpaceTime is available every Monday, Wednesday and Friday through Apple Podcasts, iTunes, Stitcher, Google Podcast, Pocket Casts, Spotify, Acast, Amazon Music, Bytes.com, SoundCloud, YouTube, your favorite podcast download provider, and from SpaceTimeWithStuartGarry.com. SpaceTime's also broadcast through the National Science Foundation on Science Zone Radio and on both iHeartRadio and TuneIn Radio. And you can help to support our show by visiting the SpaceTime store for a range of promotional merchandising goodies, or by becoming a SpaceTime patron, which gives you access to triple-episode commercial-free versions of the show, as well as lots of bonus audio content which doesn't go to air, access to our exclusive Facebook group, and other rewards. Just go to SpaceTimeWithStuartGarry.com for full details. And if you want more space time, please check out our blog, where you'll find all the stuff we couldn't fit in the show, as well as heaps of images, news stories, loads of videos, and things on the web I find interesting or amusing. Just go to SpaceTimeWithStuartGarry.tumblr.com. That's all one word, and that's Tumblr without the E. You can also follow us through @StuartGarry on Twitter, @SpaceTimeWithStuartGarry on Instagram, through our SpaceTime YouTube channel, and on Facebook, just go to facebook.com/SpaceTime with Stuart Gary. And SpaceTime is brought to you in collaboration with Australian Sky and Telescope magazine, your window on the universe.
You've been listening to SpaceTime with Stuart Gary. This has been another quality podcast production from Bytes.com.